Hello folks, welcome to the part 9 video of this exercise 1.4, and this should be our last video for this exercise. We are now going to see, for the first time we have always seen a single element related to another element. Now here we are for the first time seeing an ordered pair related to an ordered pair, and it's defined like this. The question says that it's already a binary operation. The question asks us to check whether it is commutative, whether it is associative, and if identity is existing, just find the identities. So let's see how we can do it. Let's check for commutativity, associativity, and then let's check for the identity. So commutativity. Already A star, B star, AB star, CD is already there. So let's consider CD star AB. CD star AB. By definition, we know that we are going to add up the first elements and then we are going to add up the second elements. But we can analyze that A plus C and B plus D in ordered pair form is the same as C plus A and D plus B in ordered pair form, right? So because of that, it's clear that AB star CD is equal to CD star AB. So what do we conclude? That star is commutative, right? Then we will look out for associativity. So associativity, we'll have one more element. Consider AB star CD star EF. So that is A plus C and B plus D by definition, and then it is starred with EF. So we will have A plus C added to E, B plus D added to F, right? We will also consider the other way, and right. So what is it? Here this will come as C plus E and D plus F, because we'll take the first two elements, first elements and the second elements. Again, when we club these together, again we club these together, it's going to be A plus C plus E and B plus D plus F. So that's how the clubbing is going to go. Technically, therefore, if we check, this is equal to this. Why? Because plus itself is associated, so these can be equal. So therefore, if you want to can specify and write, otherwise you can write directly. It is A plus A plus C plus E and B plus D plus F is equal to A plus C plus E and B plus D plus F. These both are equal. So because these both are equal, you will have AB star CD star EF. Is equal to AB star CD star EF. So therefore star is associative. That's about the associativity. Now identity we will check. Consider AB star E1 E2, where E1 E2 could be the identity if it is existing. Right. So the first part of the definition, this much. What does it mean? That it is A plus E1 and B plus E2 giving you AB, and E1 plus A E2 plus B giving you AB. Pure application of definition, this part and this part. Now when we try to equate, this is equal to this, this is equal to this. So A plus E1 equal to A, and B plus E2 equal to B. This is another part. So what will happen? A will go on the other side, A minus A will be 0, B will go on the other side, B minus B will be 0, E1 and E2 will become 0. Here it is E1 plus A equal to A and E2 plus B equal to B. So E1 will become A minus A 0, E2 will become B minus B 0. So you have got, see, in the first case also you got E1 and E2 to be 0. In the second case also you got E1 and E2 equal to, yes, we were looking in the previous questions that this should not happen. E1 and E2 should tally. Then only the identity will be proper. So E1 and E2 from both cases is working out as 0, 0. So identity exists and it is 0, 0. So therefore identity exists and it is 0, 0. That's what it. Now we are quickly moving to the 12th question, where this is a true or false question, where you have to check whether these statements are true or false, and whatever it is you have to justify. The first subpart says that there is an arbitrary binary operation star on a natural number which is defined as A star A equal to A for all A belonging to it. That means on natural number, any binary operation, when you define A star A, it will become A. How can it be? Right? For example, you can write this as false. A counter example. The example given for this is example given ECG. Yeah, it is star B multiplication, for example. Okay, then A star A will be A into A, that is A squared and not A, isn't it? Does it become A? It becomes A squared, and A squared is very different from A in natural numbers. So that is why it's not like that when you have a binary operation A star A will become A. It does become in some cases but not always, right? So that's about it. Then they say where you have to check whether star is commutative. If star is commutative, whether this relation is true. It is true, and I'll show you how. True. Okay, so how? You first consider this part, A star B star C, right? So these are two parts. In commutativity, you can replace the parts. A star B can become B star A. So this is one part, this is the second part. They can change places. So it can become B star C star A. We have changed places because it's commutative. Now, because it is commutative, these can change places, isn't it? So this can become C star B star A. That's it, right? Commutativity twice we have used. We've got that. So it's a true relation. That's about the second subpart. Now we have our question number 3. It's a multiple choice question. It says that there is a binary operation star on n which is defined as A star B equal to A cube plus B cube. You have to check the correct answer. Whether it is commutative and associative both, whether any one of them is correct or whether none is correct. That is what we have to check. And actually the correct answer is this. Star is commutative but not associative. B is the correct answer. Now why it is, I'll let you know. A star B you already know. You take B star A. B star A is B cube plus A cube. That is equal to A star B, isn't it? Because B cube plus A cube is equal to A cube plus B cube, like that. That is why it becomes commutative. Therefore, star is commutative. But associative at the same time, if you consider A star B star C, this will be A cube plus B cube star C, which means cube of the first number, first bracket, plus cube of the second bracket. And if you take this part, then it will be B cube plus C cube. Okay, then cube of this plus cube of this by definition. And you check these values, so different. A cube plus B cube, the whole cube, plus C cube. Here A cube plus B cube plus C cube, the whole cube. We are not going to expand it, but when we expand it, the terms are really, really different. So therefore, A star B star C is never equal to A star B star C in that order. So star is not commutative. Sorry, it's not associative. So that is why we say that it is commutative, but it is not associative. So that's all about the exercise 1.4 binary operation. This was the 13th problem. Next, we are starting with the miscellaneous. Thank you.